Okay guys, and so lab 4 introduces stoichiometry and percent by weight. So if you go over to the lab 4, you will find that it begins introducing stoichiometry, and here it's got an equation for percent by weight. So obviously you will need to know how to calculate this. So here I'm going to do an example problem, which is calculate the percent by weight of magnesium in magnesium oxide. So let's go over to our drawing board. So let's say, well, we'd have to look up magnesium. So the weight of magnesium, and Google returns great results. If you just type in the weight of magnesium, it will return you the weight of magnesium. So we find that it has an atomic mass of 24.3 grams per mole, and we will find that the weight of magnesium oxide, well, this is kind of cheating, so I will actually I'll type in the weight of oxygen, and so that's going to give me about 16 grams per mole. So let's calculate the theoretical percent by weight of magnesium in magnesium oxide. So the magnesium here is going to be this top guy. He's our magnesium, and this bottom guy is our oxygen. So our percent magnesium in magnesium oxide is going to be given by this equation, which is the weight of whatever you're looking at. So if it was, oxygen and water, or magnesium and magnesium oxide, it's all the same. You would put the 24.3 grams per mole on the top, and you would put the total weight of your molecule on the bottom. So we would do 24 plus 16 is 30. I'm sorry, it's 40. And someone can't do math. So we have 40.3 grams per mole, and if we calculate this out, we'll get about 60%. Okay, so that would be how you calculate the percent by weight, and that's mostly what you have to figure out how to do in lab 4. And so then in lab 5 we start getting into a little bit more stoichiometry and having to understand neutralization reactions, etc. So I've added for lab 5, you've got stoichiometry. You need to find how much of a reactant you have, and you need to know how to find percent yield. So the percent yield equation is given right here. It's just however much you actually got over what you were supposed to get if your reaction went perfectly to completion. So if you had 100% of whatever you started with, then your percent yield would be 100%, or your theoretical yield would be whatever you found. Okay, so let's go through this problem right here. We are considering this reaction, and I haven't even shown you the problem, so this is the problem. We are basically reacting sodium carbonate with hydrochloric acid in this reaction right here. So if 2.45 grams of pure sodium carbonate is treated with excess hydrochloric acid, and now whenever you see the word excess, that means that is going to be or not going to be your limiting reactant. So since we are treating it with excess hydrochloric acid, that tells us that this sodium carbonate is going to be our limiting reactant. Okay, and so it asks how many grams of sodium chloride will theoretically be produced. So let's go ahead and do this calculation. So we have, and I'll be switching between screens, so hopefully you don't get too dizzy. So we have 2.45 grams of our substance, and that is sodium carbonate. And so I'm just going to write, well, I should write the whole equation. So Na2CO3 and we are trying to react that with hydrochloric acid. Now, if we look at this equation right here, it is not a perfect ratio. If we go, it's basically telling us that we need 2 hydrochlor. Oh, is this the right equation? Well, it's close enough. It's basically telling us that we need 2 acid molecules for each 1 sodium carbonate molecule to use up. So, and also, if you ever forget what you're doing, you can find a very similar problem on page 37 of the lab manual. So basically what we need to do is we need to take this from grams into moles and find out how many moles of hydrochloric or how many moles of our product we will be forming, which, if we go back to our question, how many grams of sodium chloride. So we are looking how many of these guys will we form. So we are basically forming 2 sodium chlorides for each sodium carbonate molecule. So we would have to add up the weight of our sodium carbonate molecule and multiply that out. And so I'm going to show you a little thing that I call the train tracks. So if we have this 2.45, and I'm going to try to draw a little bit smaller, grams of sodium carbonate, which I'm just going to label as SC for now, not to be confused with South Carolina. And we are going to multiply this by something that will help our units get one step closer to what we want. So in order for grams to cancel out, we need a grams on the bottom over here, and we want to get to moles. So do we know the grams per mole of this sodium carbonate molecule? Well, I'm not going to do that calculation, so I'm just going to look it up right here. It's 105.98 grams per mole. So 100, I'm just going to round that to 106. 106 grams per 1 mole. And now what's going to happen is we are going to be able to cancel this grams with this grams, and now we are left with 2.45 moles of our substance. So that's of our that's how many moles we have of this sodium carbonate. Now we need to change that in a ratio to find how many moles of sodium chloride are going to be produced. So we are going to then need to multiply this by, so we've got moles of sodium chloride, so we then need to multiply, we will have 1 mole of sodium chloride for each 2 moles of sodium carbonate, for each 2 moles of sodium chloride. And that way we can cancel out our units of sodium chloride, sodium carbonate, with, and here's our moles. So moles cancel out with moles, sodium carbonate cancels out with sodium carbonate. Now we've got this 2.45 grams, or 2.45 times 2 all over 106, and this will give us our moles of sodium chloride that we have. So going back to the problem, it's asking us how many grams, so that's not useful just yet. We need to now convert this into a weight. So once again, I'm not going to look up the weight. We don't have it here. Alright, so I will look it up very quickly in Google. Weight of sodium chloride. That's literally what I'm typing into Google, and it's spitting back that it is 58.44 grams. And now if you wanted to calculate that, you would just find the weight of sodium and add the weight of chloride, and those two weights together would give you the weight of sodium chloride, because it's just NaCl. So that's 58.44. So I'm going to bring, running out of space, I'm going to bring this guy down here, and I will then multiply him by, I already forgot what our weight was, for 58.44 grams. And now where do we want the grams? Well, we want the moles to cancel out with the moles. So since we have moles up here on the top, we're going to want moles on the bottom. So moles goes down here, and grams goes up here, 58. And then the moles of sodium chloride cancel out with the moles of sodium chloride down here, and then your final answer is just going to be literally just multiply all the tops and multiply all the bottoms, and then put that into your calculator. So we've got 2.45 times 1 times 2 times 58, and don't forget your units, so we are in grams, all over 1 and times 106 times 1, and I forgot to say 1 mole down here, times 1, and that will give you your final result for this problem. Okay, let's go back to our sheet. So hopefully that helps for this problem. If you didn't quite follow that, remember you can always rewind. This is a YouTube tutorial, so that's exactly why I'm doing this, so that you can benefit from the fact that it's a video. Okay, so now we're told that, oh, I guess I have to do this calculation. So I will get my calculator out and type in, if we go back to here, I will type in 2.45 times 1 times 2 times 58, all divided by 106, and we get 2.68 for our answer. And so now it's saying if our actual yield is 1.54, then what is our theoretical yield? So if we go to our lab manual, we have that theoretical yield is actual yield over theoretical yield. Well, we just found our theoretical yield, so that is going to just be 2.68 and this won't clear. Let's try that again. So 2.68 on the bottom, that's our theoretical, and our actual, we were told, was, where was that problem, was 1.54. So, and don't forget your units. In this case they just cancel out, the units do, so we are left with a percent, which is going to be 1.54 divided by 2.68, so that is about a yield of 0.57, which we know is 57.5%. Alright, so that would be how you would do this entire problem. So that brings us to Lab 6. This is precipitation and finding your limiting reactant.